Let's begin with a simple RC circuit with a switch. The switch will show how we can charge and discharge the circuit as we connect and disconnect it from the voltage source. While the capacitor is getting charged or discharged, we can find VC and IC. VC is the potential difference of the capacitor, while IC is the current of the charging capacitor. These values can be represented by the following equations. V equals IC times R plus VC. IC equals C times dVC over dt. Vc of t equals V final plus quantity V initial minus V final times the exponential to negative t over tau. Of a capacitor. Let's say the switch was at B for a very long time. The capacitor is fully discharged or contains no charge. Once the switch in the circuit goes to A, the capacitor slowly begins to charge as its plates accumulate charge. Total voltage of the circuit is found by the voltage and the current of the capacitor. Current of the capacitor is changing, thus it is the capacitor value multiplied by the change of Vc with respect to time. Tau is the time constant, which is equal to Rc, which is the resistor value times the capacitor value. Initial voltage is 0 because there is initially no charge. If we make the final voltage equation equal to Vs, the equation for a charging circuit at any time t is equal to Vs times 1 minus e to the negative t over tau. Voltage and current of the capacitor change with time, thus we can represent these changes in a graph. As shown, voltage is initially 0 and exponentially increases until it levels out as the capacitor gets fully charged. On the other hand, the current starts out at its maximum value and exponentially decreases until it levels out to 0. This is because the circuit has a voltage, so there can be a current flowing since I equals V divided by R. Time can be measured by the time constant tau. A capacitor. Now let's say the switch was at A for a very long time and it moves to B. The capacitor was fully charged and will now begin to discharge as the circuit contains no voltage source. With this circuit, the initial voltage is Vs and the final voltage will be equal to 0 since it is discharging, so there will be no voltage at the end. The voltage in the capacitor can be represented by Vc of t equals Vs times exponential to the negative t over tau. Once again, the voltage and current change with time and can be represented on a graph. In this case, the voltage starts at its max value and exponentially decreases to 0 since it is discharging. The current in the circuit is in the opposite direction compared to when the capacitor is charging, thus it is negative. Since the voltage is going to 0, the current will also go to 0 since the current is equal to the voltage divided by resistance.